All right. Welcome everyone. Good afternoon. I'm Mariane Medeiros. I'm Senior Project Manager at the Northeast Recycling Council here at NERC, and I'm excited to welcome you to today's webinar, End of Life Solar Panels, Navigating the First Wave. So as the first major wave of solar photovoltaic installations in the US reaches the end of its 25th year life cycle, new and pressing challenges emerging, which is what happens to all the retired panels. And coupled with that, the recent trade tariffs and increasing domestic manufacturing, the US solar sector faces a critical inflection point without effective recycling infrastructure. Mounting the PV waste could undermine the industry's environmental credibility and create costly liabilities. So welcome again. And for today, as we're presenting the end of life solar panels, we have um, uh, a little bit about NERC and who we are. We are a nonprofit working to minimize waste, conserve natural resources, and advance a sustainable economy through facilitated collaboration and action. And what we do, we breach informational gaps across the public and the private sector, develop educational resources as this one, and advance conversations on critical issues across sustainable materials management. Our reach, we serve the 11 Northeast states and nationwide, works directly with state, regional, and local agencies, the private sector, trade associations, and others to help address sustainability challenges and achieve environmental goals. The agenda for today is we start with the introductions, we have our speakers' presentations, and then after we have the facilitated Q&A. This is a recorded webinar using Zoom meetings, and this webinar will be recording and presentations will be shared on our website afterwards. So I'm going to start presenting our presenters for today, our speakers. We have Glenn Lega from Commercial Solar Panel Recycling, John Carhart from Eunomia, and Robin Engentron from Good Point Recycling. For now, we're going to start with Robin. Robin, welcome. And Robin is the CEO of Good Point Recycling. Robin he has facilities in Vermont and Massachusetts. He previously directed the Massachusetts DEP recycling program and is a former Peace Corps volunteer in Cameroon. Robin holds a Bachelor in International Relations and an MBA from Boston University. He's also the founder of Fair Trade Recycling and has been recognized by Recycling International as one of the top 100 recyclers worldwide for 4 consecutive years. So thank you, Robin, and the floor is yours.
Thank you, Marianne. Okay, I will go into present mode. It's my pleasure to be here. The first few slides here are, I'm going to go through quickly for the sake of time. They're basically about Good Point. We're going to talk today about what the problem is, what services for obsolete or not, or simply retired panels, how this could be a revenue stream, and our business model. We've been around since 2001. So we've just celebrated, incorporated 2001, celebrated 25 years this year. We've got 30 employees and 3 facilities. So the problem that we're looking at today is that new solar panels are becoming cheaper and more efficient, while the new farms, these fields where you see them, are getting harder and harder to site. Particularly in the Northeast and California, where land is very expensive. The analogy I sometimes make is, if you remember what the old 17-inch CRT monitors, the amount of space those took on your desk, that we're seeing more and more of these fields replace 200-watt and even 300-watt panels with 500s. So that's causing us to really look at what the definition is of the end of life. And I've got a little video here of a 1978 40-watt solar panel, which you'll see here is powering a radio, speakers, charging a mobile phone. and a desk lamp. And when I walk in front of it with my shadow, it goes off. Um, Sorry, that's freezing. That has caused my screen to freeze. Can you still hear me?
Yes, we can hear you, Robin.
I'm going to stop sharing momentarily and then go back. Sorry about that. So we worked very closely with the German engineering student at the University of Rhode Island in 2020 and 2021. In his thesis, he's still in the industry. He was looking at how to grind up solar panels, and his challenge was to have the end of the grinding up process actually produce less waste and carbon than simply not grinding them up. And that's where he looked us up because he was researching reuse. And he said, you know, all of the panels, when he was trying to source them for his research, he found had been electively replaced because they were just old, that he didn't find any evidence that they weren't functioning. Um, and so he said even the hail damaged ones, like the ones in this photo, he was finding that they were, 50% as efficient, but still working. And
Robin,
so,
could you put in presentation mode, please?
oh, sorry.
No.
What have I done?
That's it.
So he
Thank
was
you.
looking at how when these things make economic sense to replace, and found that as the efficiency is going up and the price is going down, he said, look, every panel that's more than 10 years old in the country, he thought is going to make sense to replace in 2029. Now, we don't know if the tariffs are going to change that. And if the tariffs do change it, we're concerned that the Chinese are still going to be making them. So they might start putting them into the same markets we're looking at for reuse. Um, but anyway, the good news is that these things are not necessarily junk. And like flip phones and CRT monitors before them, most of the solar panels may have a market. So we're right now working with a group of 12 African entrepreneurs, most of which I've worked with for years and used electronics, but some of whom are finding us who are already in the solar panel business, and we want to keep that going. Emmanuel Nialite, shown here, has started a company, bridgesolarpower.com, in Ghana. This is him making a presentation at the European e-waste conference in Salzburg 5 years ago. Emmanuel used to work for me here at GoodPoint and has become a coder and is really great. There's another company just contacted us this week called Rudy Solar, which is in Uganda. And his website, like Emmanuel's, is really set up. And there are already conferences taking place to really attract the African market because uh, Africa's electricity usage keeps growing. The population is increasing, it's urbanizing, and they're suffering brownouts and blackouts. But unlike in past years, they don't really have hydroelectric dams. There's no more rivers to dam up. So most of the increased demand in Africa is being met by diesel electric generators. Um, that's going to create an opportunity for us. I'll now show you a video where we'll terminate my session in case it crashes. This is shows a grant that we got from Massachusetts DEP this year to be able to track the panels using GPS codes so that if people ask us, well, how do you know that it's really in use? That Africans with their cell phones can take a picture of the blockchain. I'm sorry about the ad.
believe it's freezing again, Robin.
Okay. Sorry, that worked in practice mode. I'll put up a link to that video later. But basically, it demonstrates the technology that we can put a QR code on the panels when they're still in the field in Vermont or Massachusetts or anywhere in the country. Take a picture of it, upload it to our partner TradeLoop, where the image in every cell phone photo has got a GPS coordinate locked in. So it shows it on the map where that panel is in Vermont as it's being replaced. Then we'll take a picture of that QR code when it arrives at our facility in Vermont or Massachusetts, and it will then geotag it, show it that's where it is. Our partners in Africa uh, are given a financial incentive to take a picture of it as it's offloaded. And then if you want to find out where your panel is, because the QR code is all tracked on a blockchain that can't be faked, can't be changed. If you ever want to find out, hey, what's this panel doing? Look up the GPS code on Google Maps and you'll see, oh, it's at a hospital, or oh, it's at a church, or it's at a school. No evidence that it's being burned by children, which there isn't much of an economic case for that model in the first place. But we're anticipating that people are going to have these concerns, and that's what this grant is for. So with that, I'll turn it over and stop my screen share and look forward to answering questions.
Thank you so much, Robin. Thank you for your presentation. And just to remind everyone, you can add your questions to the Q&A box right on the bottom of your screen. And then we'll have all those questions asked by the end of all three presentations. Now we're going to go to our second presenter, which is John Carhart. John is a senior consultant and lead modeler at Eunomia Research and Consulting in New York. He led the quantitative analysis for Minnesota solar PV reuse and recycling needs assessment and has extensive experience modeling the impacts of extended producer responsibility and deposit return systems across North America and Europe. John holds a bachelor in economics and environmental policy from Colby College. Welcome, John, and the floor is yours.
Thank you very much. And can I just confirm that my presentation is showing?
Yes, it is showing.
Cool.
Thank you.
Thank you. Yeah, so as Marianne mentioned, I'm a senior consultant at Eunomia Research and Consulting. We're a circular economy focused consulting firm. We have one office in North America located in New York, and we focus on circular economy projects, looking at mass flows and sort of cost-benefit analyses of circular economy policies. So I'm going to be speaking about a specific project which we conducted for the Minnesota Pollution Control Agency, or MPCA, last year. So in 2024, Eunomia was commissioned by MPCA to analyze the cost effectiveness of different policy measures to handle end-of-life solar panels. So the state has had a pretty robust installation history over the last 5 to 10 years, and they are starting to look towards how best to handle these solar panels once they become offline and reach a sort of end of useful life. So the first part of this project was to estimate the expected generation of solar panels reaching their end of life from pretty much 2025 through to 2050 in the state of Minnesota. We then conducted stakeholder outreach and quantitative modeling to analyze the impact of different policies for managing solar panels, as well as a sort of business as usual, no policy scenario to see what these sort of additive benefits are of the different policies which we were exploring. So the stakeholder outreach included putting an advisory board together, which had industry experts, associations, and private companies as a part of the group. And in the end, the project was submitted to MPCA, who then summarized and submitted the report itself to the Minnesota State Legislature. So that was sort of the overarching objective of the project itself. And as I mentioned, the first part of the project was to analyze what has happened already in Minnesota and the solar panel installation history in the state. So on this chart, you can see that from 2017 to 2023, there was a acceleration in the installation of solar panels in the state, and these installations have been split by the type of sector or installation which they were addressing. So you can see that the largest bar here, the pink bar, is a community solar garden sector. So these are the sort of subscription model for smaller scale installations which residents can sign up for and draw power from sort of decentralized community solar gardens throughout the state. Whereas the sort of green teal bar is the utility scale installations in the state. And what I had expected to see when we first dove into the data for Minnesota was that the lion's share of the installations would be these sort of utility scale installations. However, the community solar gardens have really driven a lot of the installations in the past couple of years in the state. So that was an interesting finding for us, and one that has implications for what types of policy and collection infrastructure will be needed in the state. So you can see that, yeah, those were the two largest sectors which had the solar panels installed. And then there are also a number of residential and commercial, more sort of solar or sort of rooftop solar installations that folks might put on their houses or their own businesses. But all in all, there is a sort of large increase over the past 5 to 6 years, and the state is wondering when all of these reach their end of life, what might be the best way to handle and prepare for that scenario. So when we looked back at the installation history for the state, we then had to project when these solar panels may actually come offline based on the sort of average useful life of the solar panels. And it appears that around 2040, there will be a very large spike in panels coming offline in the state. And as Robin mentioned, that could be brought forward if there are advancements in efficiencies and some of these panels get swapped out ahead of this timeline. But this is sort of based on the average panel life that is in the industry right now. So as you can see in 2040, based on the installation history of the panels and the sectors that have been driving the solar sector in Minnesota, the majority of panels which are going to be coming offline are these community solar garden and utility scale panels. However, there are just under 100,000 solar panels per year, which will come offline from the commercial and residential sector, the more rooftop solar panels that might be a bit more difficult to get to economically for end of life management. So there is a need here for having to design infrastructure and collection based on what type of solar array you are collecting from. So this sort of finding and landscape review led us to a scenario where we matched and devised different collection infrastructure and systems for different sectors. So it was clear that there couldn't be a one-size-fits-all solution that worked for each sector within the state. So
John,
yes, sorry.
Would you be able to talk just a little louder? Some people are finding a bit difficult to hear you.
Yes.
Thank you.
Sure. So based on these end-of-life generation findings, it was clear that there couldn't be a one-size-fits-all solution that worked for each sector. Therefore, Eunomia and the stakeholder teams designed different management configurations for different sectors. So Eunomia analyzed mixing and matching different systems, each with variations in collection infrastructure, funding structure, regulatory setup, and recycling requirements. In all, Eunomia modeled 5 alternatives to the status quo in Minnesota. These types of systems modeled included expanding the existing decommissioning requirements for large-scale installations, indirect policy such as disposal and landfill bans, and more direct policies such as collection and recycling requirements under permittee pay structures, as well as extended producer responsibility. So in all, we had 5 scenarios here where, depending on what sector the solar panels were being generated from, they would have their own collection and management system. So just as an example, for scenario 5, we had utility scale installations having a decommissioning plan, which exists already in the state for all installations greater than 1 megawatt. However, for all other types of solar installations, an extended producer responsibility program would be set up to manage those end-of-life panels. And this was meant to look at how best can we holistically manage the end-of-life solar panels when there is such a diverse set of arrays and installation types throughout the state. So what we found was that high recycling is achievable under pretty much all scenarios that do include some sort of policy. So in 2040, we see that the 6 scenarios that have either a sort of indirect landfill ban or decommissioning threshold policy, or a more direct extended producer responsibility or permitting pay structure. They all have recovery rates that can reach above 80% for end-of-life solar panels, whereas under a no new policy scenario, roughly 42% of panels would be covered and collected under that type of system. So in Minnesota currently, there is a decommissioning requirement for large-scale solar arrays that are greater than 50 megawatts. However, each of the other types of solar installations, the community solar gardens, the commercial residential sector, the sort of industrial sector for private plants, those tend to be lower than 50 megawatts, as well as a good amount of utilities scale installations, which are also fewer than 50 megawatts. So it was clear that in order to handle all of those different installations, that we would have to address those with a new set of policy, which is why the no new policy tends to leave out about 58% of the solar panels, which will be reaching end of life in 2040. So these were these benefits to passing and having some sort of management structure for solar panels today. So trying to establish a system today and then seeing the benefits later on in 2040. And with that, I will pass it on to you, Marianne.
Thank you, John. Thank you so much for your presentation. And now we're passing to Glenn Laga. Glenn is president and co-founder of Commercial Solar Panel Recycling, CSPR, based in New Jersey. He leads nationwide efforts to reuse, repurpose, and recycle end-of-life solar panels, helping to divert them from landfills and build a circular economy for the solar industry. Before founding CSPR, Glenn built Guardian Data Destruction into the nation's largest provider of on-site data destruction services. He's an active member of SCIA and SWANA, committed to advancing sustainable, transparent solutions for solar panel waste. Welcome, Glenn, and the floor is yours.
Thank you, and hello, everyone. Pleasure to be here, and I hope everybody takes a little bit of information away and enjoys the presentation. Next. So about us. We're located in Phillipsburg, New Jersey, privately held, zero debt free, very stable in the company. Everybody has what they call sweat equity into the company. So everybody's driven by the same goal to keep the solar panels out of landfills and make sure that we are able to utilize what the byproducts are back into a circular economy. We're the first and only authorized DEP permitted recycler in the state of New Jersey. And we have a facility in California, and a consolidation location in Texas. So our basic services are recycling. We do a lot of logistics. So if the customer has the panels at their location, we can pick them up and bring them back. We do some resale. There's a certain cut line that we have for different size panels and wattage, and the consolidation program works well for small quantities to build out truckloads. Next. So, as we all thought, solar panels last forever, but there are causes for early loss. Next. You have the abandoned ones with no maintenance. Next. Improved technology, which is really, really driving the market now for the solar farms. Next. Natural disasters, a lot of storms, hail damages, um, vandalism, restructuring of the roofs. We're doing a project now for a national chain where they have to redo all their roofs, so they're removing all their solar panels on their warehouses. And defective ones from the manufacturer that either break in transit or they're not working. So there's a number of different ways, but yes. So how many are there coming offline? How many, where are they coming from? This is all good information for everybody to take down. But as you can see, in 2024, you had a total 219 gigawatts installed. Okay. And as you see how the utility lines are the ones that are really growing rapidly in the field. And let me just move my slide here a second. By 2029, it's going to double in size. So the capacity that we're going to have in the field is going to be a lot more than we have now. So, and that's going to result in much more recycling. Next. So if you look at the numbers, the generated e-waste in 2030 is going to be 55 million pounds, 5,500 million pounds, which is quite a bit. And our goal at Commercial Solar Panel Recycling is to make sure that they don't end up in landfills, and we find the proper way to dispose of them and reuse them and produce products that will come out of the byproduct of the recycling of the solar panel. Next. So this chart shows the waste growth projected versus early loss. So the early loss scenario is in the very, very light gray. Excuse me. The early loss is in the very dark gray. The regular loss is in the light gray, which is not as extreme as the early losses. So as you can see, the scale of early loss is really in the same path as the regular loss, but both combined represent quite a large number of solar panels to be recycled. Next. So by 2030, estimated that you'll have 1 million tons of PV waste. So that's 40 million solar panels by 2030. Next. So what are our options? Where do we go from here? What do we do? So we analyze the panels as they come in, and based on a cut line, we'll produce a remarketing program for our customers where we try to find secondary uses for them. And if they're not damaged, and if they are damaged and they're not working, we keep them out of landfills by recycling them. Next. So by extending the life cycle for PV panels, we look for bus bar corrosions, snail's trails on the back of the panels, intact wiring and electronics, make sure that the tips are not cut, make sure that the J boxes are still on there. Damaged frames we inspect for, no glass damage or scorching marks, minimal cell discolorations, and the wattage and ion efficiency and the actual physical size. What's really important about the physical size in the reuse is that if there's existing uh, solar arrays in place, if one goes bad, you have to replace it with the same size and same wattage. So it's a lot of times they're very hard to come by on the older arrays. So we try to keep those a good assortment of the different sizes available for the reuse market. Next. So again, our goal is to keep everything out of the landfill and to recycling. So right now, 90% of the discarded panels end up in landfills. And we are steadfast in making sure that that changes, and that's our goal, to make sure they stay out of landfills. But just imagine how much 3,000 football fields would be worth of panels going into landfills. Next. So what are we doing about promoting change? Well, right now, the only county in the United States that requires recycling is Niagara County. Our facility in California is where they're considered universal waste, so we're recycling them. You can't land them in the landfill. And in New Jersey, we're working with Senator Bob, who's introduced legislation that's going to mandate the recycling of solar panels in the state of New Jersey. And we're hoping that this law will be in effect and enforced by the end of the year. Next. So there's no law, then why recycling? Again, it's the individual's responsibility to make sure that they're doing the right thing. Landfill policies are going to change, and people are going to start to reject the solar panels from landfills. And the environmental responsibility of the owner of the panel really matters to us because we want to make sure that they're doing the right thing for the planet. The Green Initiative, and then like there are companies right now that we're working with that are manufacturers that are saying, okay, we want to be ahead of the curve. We want the market advantage in saying that we already have a downstream recycler in place so that if the air panels are coming off market or coming offline or being replaced with our panels, we have a solution for you. And proactive risk management. We don't know what's going to happen to the panels if they end up in landfills, whether or not they're going to go back to the owner and say, okay, now you have a fine because the law has changed and they have to be removed, or who knows where the possible, risk involved in this is. So next. So our recycling process begins with scheduling the pickup. And as you can see, it goes all the way through to sort and verify, then we inspect, then we inventory everything. We inventory the panels from the manufacturer, the wattage, where they came from, how many, the voltage. And then at that point, if they're going to take the path for remarketing, we have all the information on that. If not, they go back to the recycling stream where the J boxes are removed and then the aluminum frames are deframed and the glass is separated. And then we send it out to our glass processing plant where it gets shredded and sorted. And then everybody ends up with a certificate of recycling and reporting showing that the panels were either remarketed or recycled. Next. So what's recyclable in the panels? So you have the glass, which is the majority of the panels. It's about 80% glass. You have the cables that come off the back of the box. Those junction boxes also sit on the back of the panels, which the cables are connected to. And then you have the aluminum frames. So those are the basic four components that are produced by recycling solar panels. What do we do with them? So our downstream next, I'm sorry. Next. So our downstream products is where we get excited, because this is something that we're developing on an ongoing basis, and we're trying to reuse the byproducts back into the circular economy. So in our glass separation and crushing operation, we crush the panels, we separate the back sheeting. The back sheeting then goes downstream to a smelter where the the backing and the cellular cells are all smelted, and we have some sort of byproduct. The cullets go all the way down to finely ground, and they're in use for the finely ground is used for sandblasting and preparation for painting. The colored size are mixed with the pavers that you see in the middle, and those pavers are in a prototype right now. We're developing a paver that's mixed with plastic bottles and the glass colors from the solar panels, and we'll have those on display at the RE2 show, RE Plus show in Las Vegas coming in September. And what's another interesting one is that the glass we're working with Andela Ruby Lake Glass, which takes the glass colors and colors them and uses them on roadway pavement and cinder block pavement for bike lanes, safety lanes, walkways to give them a durable surface with a color, a very bright, vivid color, so everybody's aware. Next. So, how can you help us? We're here to support you guys. We're here if you have panels. We can find a program for you. We have the ability to pick them up from locations. We have a great sales force that's supporting your efforts that will guide you on how to advise your customers, how to make sure they're doing the right thing. We have white papers that we can also share with you regarding, what different projects we worked on and the benefits to the customer. And our goal again is to make sure they stay out of landfills and their byproduct is back into the circular economy. Thank you, everyone, and I hope you came away with some information that's useful. And this is my contact information, and we're here to support anything you need from us. Thank you.
Thank you, Glenn. Thank you so much for your presentation. And now that we've heard from our speakers, of course, we're going to open up for the Q&A part. I'm going to go on the line of questions here and moderate the discussion, but please add your questions to the chat box if you have any more questions. First question is not really a question, it's a request from Robin asking if saying solar panels disposal and replacement opportunities would be useful to know more about for our region and state, which I believe it's for each region and state. If any of you, could you please share materials at the end of the presentation?
Sure. I would certainly like to share with everybody the link to the YouTube video that I wasn't able to play.
Yeah.
We have three of them, the one demonstrating how the panels can be tracked and accounted for on blockchain, which is 3 minutes. We've got the 30-second one showing it kind of demonstrates where this 30-year lifespan came from to sell to the federal government. We ran across the same thing with computers back in the 90s, that when the federal government makes a purchase, to sell to the federal government, you have to declare how long your device is going to last. So when all the first solar panels were sold to the government, they didn't know how long their panels were going to last. So they wrote down 30 years because you had to write something down. That's the exact same lifespan for the 286 computer that was sold to the government back in the early 80s. Yeah, and the third video, which is 10 minutes long, to try to assuage people's concerns, we've set up a solar panel home here in Vermont in Virgins, which we filmed. It's 100% off grid, powered by solar panels that were hail damaged and are only 60 to 70% efficient. But we demonstrate that if it's free, you just put twice as many panels on the home, and you can visit that house here in Vermont, or visit the video where you can see one of our African partners standing on the roof as part of the presentation.
Thank you, Robin. Any comments from John and Glenn of materials that can be shared per state or per region?
Just the white papers that if anybody needs them, they can contact me through our email.
Okay, thank you.
I should say sorry, I should say we're also managing solar panels from across the country. It's a matter of whether there's a shippable quantity or not.
Okay. And for the next question, if the panels are still usable, is the newer panel efficiency that much greater to justify removing the panels? That would be for all of you.
I would say not for a residence, not for a house, because that so much of the cost is the labor. But if you've got one of these multi-acre fields, so much of the cost to get a field sited is legal, the acquisition of the land, and the permitting. And a lot of the people who operate those fields also have a warranty with agreement where they have to monitor, and if a panel falls below 95% efficient, they have to, under their contract, remove them. So that would be my answer, Glenn or John.
Yeah, I think that's what we found as well is if you have a large array where the drop-in efficiency gets multiplied by that many panels, it might be more cost efficient to have a bulk pickup and swap out the panels. Whereas if you're on a sort of household rooftop type of solar array, is it still going to power your house and it's still going to work out? That's probably less likely to be swapped out.
Yeah, my answer would be if you're in the business of making energy, you want to take the highest panel per square foot that you can put out there to produce as much energy as you can get. So that's the reason why the bigger farms are replacing them with higher efficiency ones.
Thank you. And next question is, I believe it's for Robin. Did you say all PV panels are tracked via blockchain?
That's what we're developing with our partner TradeLoop and Obata. The cost efficiency of tracking them it's going to be hard to compete with somebody who's buying the panels without tracking them. So what we're hoping to get states to do is when they purchase solar panels, put in the RFP, hey, put this QR code so that this thing can be tracked on blockchain after we stop using it. Right now, I'm having to nag our African partners to put the QR code and track them, or to incentivize them by paying them to do that. And when the more cost, if it's raising the cost to me to track it, that makes me less competitive as a recycler in the marketplace. But the technology is definitely proven.
Yeah, thank you, Robin. Another question for you, Robin, and then we can, go to a question for everyone. Do you perform any testing of the panels to inform the recycling reuse decision? If so, which types of tests? And I believe this can also go to Glenn or John.
What we do with any of our shipments to we've made them to Ghana, Angola, and Cameroon so far. We've got another one set up to go soon to Sierra Leone. What we've been doing, any panel that leaves our dock, it has the African there to observe the load, and we've got an African American solar power engineer who referees the load, who comes and inspects them and says, you're going to have trouble, with this one. This is don't ship this inverter. It's a 110 volt inverter. So he's helping to educate our buyers because we want to win-win. We don't want anyone to be disappointed.
Thank you. Any comments on that too, Glenn or John?
Sure. We do physical inspections when we receive them, and if there are any damages, like we discussed before in the presentation, we separate them out and they go to right cycling. And then the higher wattage panels will test to see where they are in wave number of the efficiency. But again, there's no guarantee, and we just make sure that we're able to resell what we consider the best panels that are in our possession.
Thank you, Glenn. All right. A question for you, Glenn. What should the wattage cut line be for the reuse?
Well, we're seeing new panels between 500 and 600 watts now. Our cut line for resale is at 300 watts. So anything below 300 watts, we're recycling. Like for example, we just worked with Robin on a donation program that was an entire container of 240 watts that went off to one of his clients in Africa. So, there are exceptions to all the rules, but for rule of thumb, I would say anything below 300 watts, recycle. Anything above, we try to resell.
Thank you. Another question here, I believe all of you could comment. Is there any mechanism for donating used panels for charitable use?
Yeah, that's part of what we're working on. We hope to incentivize it. I saw that Emmanuel Nailiti is actually one of the participants that submitted a comment on this. So he's more of an expert than I am. But he told me about how in Accra, Ghana, when there's a brownout, blackout, because there's so much consumption of the electricity that the grid gets stressed out, and that they actually rotate blackouts for everybody to share the shortage. And he was pointing out to me that during that time, barbers are out of luck, that they're unable to use their hair cutting and make any money. And so but they don't have a lot of money to buy panels, and they don't need much power. 100 watts plenty for a barber. So what his business is exploring is to rent them to barbershops. Put the 50-watt
Okay.
panel on the barbershop, and then the next blackout comes. All the other barbers are have lines out their door because they can't cut hair, and they see, oh, everyone's going to the barbershop that's working, so they all want panels. And then once they've seen that it works, well, who gets their hair cut? Everybody. So everybody gets exposed to this, and that there might be a great market for basically acting like a utility, collecting a rent fee every month from people who've got the panels, so that you're not only reselling them, which is a capital constraint for a lot of legitimate uses.
Thank you. And a question for John. Were installations on schools included in the study in Minnesota?
Yes, so depending on how they were classified, they would be included depending on their wattage. So they were grouped, either in that sort of less than 1 megawatt bucket, or the sort of 1 to 50 megawatt bucket, depending on their size. And so we would have devised a sort of collection methodology for schools depending on the number of solar panels and the solar arrays which existed on those arrays. So if they were below a certain threshold, it might be a sort of drop-off collection type of system for the schools. And then if it was a larger array, potentially a bulk pickup, but I think more likely it would be sort of the smaller, less than 10 megawatt type of installation.
Yeah, and I think on another question that is also kind of related to the study in Minnesota for you is asking currently in Minnesota for 50, I think, megawatt plus, this commissioning plans are required. Did I hear that recycling is also required?
Their recycling itself is not explicitly
Okay.
required. It's just, yeah, you must have a decommissioning plan for your solar array that is greater than 50 megawatts, which I think in the state, I think there are only about 6 or 7 current installations which are above 50 megawatt. The rest are under that threshold as it stands right now.
Thank you. And a question here that I believe could be for all of you. Aside from transportation, which is its own cost, how do you characterize recycling cost? Example, is it $20 a panel or higher? Glenn, you could go first, I think.
Thank you. Thank you.
Yeah.
Our biggest competitor right now is the landfill. And the landfill is the cheaper way to dispose of the panels. So for us, we want to get as close to that landfill mark, but yet still have enough money to cover our overhead costs. But SIA is saying that the average price for a consumer to recycle a panel is $20. And it depends on quantity and location. So, but yeah, I would say if you use that $20 number that SIA has put out there is a good starting point.
Thank you.
We charge $25 to $30 a panel. Sometimes we'll negotiate on something different. But the way I explain it to people, I say it's just like when people ask me what my fee was when I started Good Point 25 years ago for a CRT. And they told me, the hazardous waste shredders are charging me 50 cents a pound. What are you going to charge me? And I told them, right now, I'm going to charge you 50 cents a pound because I've got to vet all of these reuse markets. And that's costing me a lot of money to fly over and visit the places and vet them. The difference is the shredder is going to be charging you 50 cents a pound forever. Whereas I was able to get the cost down to 15 cents a pound within 4 or 5 years. It's just right now at the beginning, yeah, we're charging the same thing that we're going to be charged if we can't move them. But we're using any reuse income, putting it right back into the development of our markets. We want our buyers to be winners.
And I think in our sort of stakeholder consultation and review of costs which have been quoted, it's a similar range of $20 to $25. But it's difficult to say, given a completely mature market, where will those prices go? We're still in the sort of beginning stages of mass recycling and collection of this material. So I agree. I think there's potential for it to go down.
Thank you. There are 2 questions from the same person about Massachusetts, like asking if there are specific policies governing solar panel recycling and reuse there, and also if there are any decommissioned solar panel collection sites, which is kind of the same in Massachusetts. So if you have any knowledge of that.
We have our facility in Brockton, Massachusetts, and are opening next month a second facility in Springfield, Mass. And we've got trucks, so we collect them from across the state.
Thank you. And another question here before John. What are the different collection pathways and how do they vary by sector?
Right. So within Minnesota, we sort of set up some more direct to array collection for the larger scale, utility scale, and some community solar garden installations. That would be sort of a truck collecting directly from these arrays and sort of heading straight to a recycler location. Whereas for the sort of smaller scale installations, we had a more decentralized drop-off and consolidation center model where various different installations could bring their panels together, and you sort of build up that warehouse storage first and then have the delivery be sent to a recycler in order to sort of minimize transportation costs. But that was all, that was all part of the different types of collections, which were modeled in each of the 5 different scenarios. So we varied that by each scenario. So if you'd like to check out exactly what was modeled for which type of sector, the full length report goes into a lot more detail on how that worked in our model.
Yeah, thank you. Any comments on that, Glenn or Robin? Okay. So there's a question here. I believe it's for Glenn, but I'm not, but everyone can comment, of course. So please explain the difference between a solar garden and an industrial installation.
Industrial installation are utility scale operations. There is a law in New Jersey now that any brand new warehouse has to have solar panels on it. So that would be also an industrial scale. Um, and then solar gardens, I don't have a good explanation for that for you.
Any comments on that, Robin?
I'd never heard the term solar garden before John used it.
Sure.
So
Yeah, I mean, I could speak to it in the Minnesota context at least. But it's essentially a sort of smaller scale array that consumers can subscribe to directly rather than um, rather than a utility setting up a larger sort of solar acreage farm. It's probably small. It's a little bit smaller than that. The average wattage for community solar gardens are more between 1 and 10 megawatts, whereas for the utility scale they're probably more above 10 and 20 megawatts. So it's a bit more of a decentralized model, and the operator, I believe, does not actually have to be the utility itself, but the households can subscribe directly to those solar gardens as opposed to getting their electricity from another sort of more mainline utility.
So are they community solar? Yeah, they are community.
Yeah, the community sort of managed and run.
like the vegetable gardens in Brooklyn.
Exactly.
Cool.
And I believe this is a question for Glenn, but also any of you can answer. What are current shipping processes like? Does your company use hazardous waste manifest? I believe manifests, yeah, to document movement of EOL SPs. And what about the DOT packaging requirements?
Okay,
Those are
so
2 questions in one, but yeah.
all right, so anytime we have a shipment, we send out a packing list, and the packing list gives you specific instructions on how to palletize the pallets for safety reasons, as well as having the ability to ride either cross country or regional, wherever it's being from. Each shipment has a bill of lading, and the bill of lading is tracking in it, and it also handles as your transfer of ownership at that point too. So your chain of custody also follows with the bill of lading, and then your final documentation is a certificate of recycling.
Thank you. Any comments on that for John or Robin? Okay. Robin, I have another question for you for solar panels reused in emerging markets. What will happen at the end of their newly extended life?
Quick answer, the same thing as will happen at the end of a brand new product's useful life. I was always asked that question about, flip phones and used computers and used TVs. And yeah, eventually anything, but we didn't have to say what we were going to do with the new ones in the future when we bought them. So to try to tell Africans that we don't trust them with it really ignores the history, which is very well documented by World Bank, International Monetary Fund, and I've been participating in this for 25 years. Africa in 2017 had 170,000 cell phone towers. A cell phone tower costs hundreds of thousands of dollars or $1 million to put up. Who is paying for that? there aren't enough new phones to account for those. So what the used equipment does is creates what the World Bank calls a critical mass of users that allows investment and progress to happen. And I could see this because it was exactly the same for my grandparents in the Ozark Mountains, who grew up before there was electricity and paved roads. So what we want to make sure doesn't happen, back when people weren't sure about the reuse of electronics 25 years ago, a lot of very good people chose not to make their product available, but the demand was still there. So they had to buy from bad people. They had to go into back alleys. So if we can have, all the answers for everybody, but we're trying to make sure that this time that the Africans are at the table and are very involved in this discussion. And, everyone that I'm working with is an adult, and nobody I'm working with wants to lose money. They only make money. It costs them about $25 just to ship a solar panel. So every one that they've got to bring through customs, they're gambling that it's going to work and be productive for them. There's not enough raw material for these things to be shipped based on scrap value. Would you agree, Glenn?
Yes, and another interesting fact is that right now we're seeing a lot of requests for decommissioning and recycling plans before the fields are being implemented on the utility scale. So they want to know the county or the residents where they're being built. They want to have a plan in place for the decommissioning and the recycling of the panels before that project's even started. So we're seeing quite a bit of that now, which is it's moving in the right direction.
John, any comment on that?
Yeah, I think to what Glenn said, the sort of preventative decommissioning, and sort of trying to expand on what is required within that. The earliest possible stage is a good place to start.
Yeah. And linking to that, I have a few questions here also about the market. But as we were talking about market overseas and also the effect of the tariffs on that, are there then options here in the U.S. For that market, and what are they? And also adding to that question, with those options here in the U.S., how the policies play a part on that. So that would be a question for everyone. I think John can start.
Sure. So this is to do with the general market for end-of-life solar panels, given the current state of tariffs. Yeah. I think there is value in various parts, and co-presenters will attest to, in various parts of the solar panel, and getting to maximize the value that you recover from the panels, because there's different intensities which you can recycle. I think trying to increase the intensity of the weight captured from the panel itself can increase your overall revenue that you get from the panel. So I think especially if it becomes a bit costlier to find material from importing the sort of raw materials for these panels, as you increase the domestic collection of these panels, I think the revenue can realize savings by capturing that material that is coming offline within the next 10 to 20 years. So I think it's important to ensure you're collecting as much as you can once these panels start coming offline, and then setting up a sort of transportation logistics system that sort of minimizes how much it'll cost to to ship those panels to a recycler. Maybe that's a sort of decentralized, smaller scale recycling program for small scale installations, and then you have your sort of larger scale recyclers that may have a further shipping distance, but I think there's different ways to play it so that you can sort of minimize the cost of that.
And the other question I did, just to add to that, was how policies affect that.
Yeah, I think particularly when we looked at recycling targets and you know depending on how you measure your recycling, if it's sort of a weight based or a value based or a sort of material by material within the solar panel recycling metric, each of those can drive how much of the panel will eventually be recycled and turned into a new product. So I think, yeah, that's a question which is still in debate now, is what is the metric we are going to use to measure what is achieving a quote recycling target under policy.
Thank you. Robin, any comment on that?
Yeah, you mentioned the tariffs, and I would add to the tariffs the sunsetting of the tax credits for Americans to invest in renewables. And we do expect it's going to have some effect, but it's going to have an effect on a known transition, which is prior to those changes, we saw for sale used solar panels on Facebook Marketplace dropping in price, and do-it-yourself market getting pickier and pickier and pickier. And that's exactly what we saw with used electronics over the past 30 years. That you'll have a brief window when a rich nation has some people that are willing to buy. And it might be that the tariff, since 80% of solar panels installed in the last 5 years within the last 5 years were manufactured in China. So it may be that, the elective upgrade business slows down, and it may be that the Chinese start to sell the panels that aren't selling into our markets in Africa. We don't know, but we do know that rich people don't use stuff for as long as poor people do. And we also know that Vermonters get a lot less sunshine than people in sub-Saharan Africa.
Glenn, any comments on that?
Yes, the tariffs could work twofold. It could work against us when we're selling to third world markets, because if we have very high tariffs on the Chinese imports, they're going to dump their product elsewhere throughout the world. And then that would affect our market for used solar panels going offshore. On the reverse side, if the tariffs are high for Chinese imports coming into the United States, the used solar panel market in the US might flourish because of the cost of the new panels coming in.
Thank you. And another question here is, how do energy prices affect the incentive to replace PV panels? And putting in another way, do higher energy prices make it more or less likely that PV panels will be replaced before UL?
Oh, I'm glad you asked that. Yeah. That's a great question, and I forgot how important that is, because the price of electricity, I was just hearing on NPR yesterday, has gone up 40% in the last 5 years, and that might overpower the negative effect of the tariffs.
Yeah. Any other comments on that from Glenn or John?
Yeah, we were just at a meeting in Jersey, and they realized that the cost of energy is rising drastically. We're almost in some sort of crisis now, and the only way to reduce it on a scale that's sustainable is to install more solar. So Jersey is really looking at installing more solar to help reduce the energy costs in Jersey.
Perfect. Thank you. A question for you, Glenn. For those crystalline PV panels, what happens to rare metals in those PV panels during or after recycling? Example, lead and silver.
Can you repeat that again, please?
For those crystalline PV panels, what happens to rare metals in those PV panels during or after recycling? Example, lead and silver.
Okay, so the lead and silver is in the solar cells in the backing, and that gets sent off to a smelter for smelting.
Okay. Any comments on that, Robin or John?
I don't know. I know that I'm very happy that they stopped putting cadmium in the panels about 20 years ago. And since so many fewer were sold back when had cadmium in them, that means that a very small percentage, it's kind of like monochrome monitors back 25 years ago. Yeah, there were a few non-color monitors out there, but a lot more of them don't have cadmium in them.
I think, Glenn, correct me if I'm wrong here, but I think the amount of silver that is in the newer age panels is starting to go down. Is that correct? As a proportion of the actual panel itself. So it's less of a part of the stream for the panels coming offline in the next decade or so.
Less silver.
Okay.
Yeah, I believe so.
Yeah, that's part of how the price is going down, is that they realize that they used to build computers to last 30 years. That's why there's so much gold in a 286, 46 computer. They didn't know that software was going to render them, replaceable. And they're now learning the same lesson with all electronics and with solar panels that don't plant. You can make more people buy them if you don't put as much silver in them.
And another question on the material in the solar panels is asking about the recovered plastic. What is done with it?
The plastic backing that's on the backing sheets goes to the smelter as well, and it burns off during the process.
Okay, thank you. It's asking for Glenn and Robin, what are your findings about the frequency with which panels are found to be hazardous? Are there any apparent trends, like date of manufacturer, mode of use? What are your thoughts on that?
We only handle mono and polycrystalline panels. The cadmium panels that are produced by First Solar, they have their own recycling program, so you can ship them back to them for recycling. But yeah, the cadmium panels we do not handle whatsoever.
I have yet to see any, unless there was some in that Jimmy Carter 1978 panel, and that one, that panel still works.
Coming off the White House.
Yeah.
Thank you. A question for John. What was scenario 3B, and how would different sectors panels be addressed to ensure recycling?
Sure. Scenario 3B.
Yeah, there's a specific question on your PowerPoint.
Right. So scenario 3 in general was a permittee pay structure for the management of all solar panels that were under the decommissioning thresholds of a smaller scale panels. And we had two variants of that. We had one where you had your sort of as is recycling for solar panels, the actual recycling stage of dismantling and capturing the end of life materials within the solar panel. That was 3A. And then 3B was sort of using some more of the theoretical research recycling programs that are attempting to capture as much material as possible from the solar panels. So that's a bit more capital intensive up front, but the amount or percentage by weight of the panel which is collected goes up using those methods. And I think that is something which is still in testing, but we're assuming that within 20 years, it was a 30-year horizon for the project. Potentially that type of recycling becomes a bit more mainstream in the future. So that was sort of the 3B scenario. Yeah, and sorry, what was the second part of the question?
It was, and how would different sectors panels be addressed to ensure recycling?
Right. So we did the real differences in how panels were collected and transported within our study were based on their the wattage of the array. It just so happened that the large scale arrays were utility scale and some community solar gardens. So those would be, as I mentioned, sort of directly collected from when the panels needed to be swapped out and then sent to the national recyclers, which have the large plant facilities that recycle a large volume of recycling or a large volume of solar panels, whereas the smaller scale wattage installations, the commercial and rooftop solar for residential, those were potentially seen as having more decentralized recyclers, potentially within Minnesota, which could dismantle and remove some of the parts of the solar panel first before sending on the remainder to secondary recyclers after that. So yeah, it was really a mix and match of transportation, collection point, and which type of recycler the material was going to be eventually delivered to.
Thank you. John, I think the next question is also for you. Is there a significant cost for the generator or municipal collection program to recycle or reuse the panel that would make solar panels a good candidate for EPR legislation? And is this why your analysis showed the highest recovery rates were under EPR minus cost covered equals more recovery?
Right. So yeah, in general, there is a net cost of um, handling the end of life solar panels, which was consistent throughout our modeling. Once you include, every type of sector and size of solar array, so there is a cost to be covered under that under a system where all panels must be collected and sent for recycling. So to manage that, we did set up different types of funding structures, one of which was, extended producer responsibility, which, you know, where exactly the threshold for a line of producer gets drawn for that, I think is still an open debate, but it was sort of a thought that, the industry pays into the system to help cover the cost of managing the various solar panels which need to be collected, and that itself incentivizes investments in infrastructure and collection and management of the solar panels. So yes, it's sort of having a central sort of operating system to sort of coordinate all of the different steps in the collection and recycling chain in order to maximize as many panels being collected.
Thank you. Any comments on that from Glenn or Robin? Okay. Just a note here for everyone. We did get a lot of questions. I believe we won't be able to answer them all, but we're going to try to get there. And after the webinar, we're going to try and have them answered and send it out to and put it on our website. So a question here for Robin, I believe. One second. And also Glenn, how does the expense of solar panel recycling compare to the typical cost of disposal? If there is no landfill bin, is that potential cost differential going to create an incentive to landfill?
You'd have to repeat that for me. I didn't hear it. I'm sorry.
Yeah. How does the expense of solar panel recycling compare to the typical cost of disposal? If there is no landfill bin, is that potential cost differential going to create an incentive to the landfill?
Yeah, Glenn answered that previously, that's our competition, is the landfill. And without a waste ban, it's a little bit harder for us to develop the installation costs. As I said a few minutes ago, We started off with CRTs charging 50 cents a pound, but got the price down to 15 cents a pound once the proven reuse markets, were developed. It just took time to prove those markets. Um, uh, we're hoping that there might be potential with this blockchain program to actually document carbon savings, because if the Africans have been using, diesel generators to generate their electricity, and we get the panels, primarily sold to people that have a diesel generator, that's going to create a record of how many liters of diesel are being saved every month, and that could potentially be something for the carbon offset market.
Thank you. Any comments on that? Glenn or John?
Our goal is to make sure they don't end up in the landfill for the environmental reason. That's our primary goal. We're not looking to, make a killing on recycling. It's, if our goal is to reuse and repurpose and recycle, that's where the value lies, not in the revenue that we have to charge to make sure that the equipment that we have to maintain and install can support the operation. And basically, that's the economics of it.
Okay, thank you. John, any comments?
Yeah, I think this is where sort of prepping for this by examining what types of policy can sort of boost the system to sort of compete with what is going to landfill. If we do that now, that can be beneficial for setting up the system to compete a bit better when all these panels really begin to come offline.
Yeah. And we have 3 questions here about what is the minimum amount of solar panels needed to stockpile for shipment?
That's an economic question. You can send a truck driver, 500 miles to pick up one solar panel, but that's going to be super expensive.
Yeah, so for us, we have a 30 panel minimum per skid, and we need to have one skid as a minimum for a local pickup.
Yeah, we don't have any minimum, but we charge the actual cost of the transport. So if you don't have more than one pallet, it's going to be a lot more expensive for us to go pick them up from you.
Thank you. There are a few questions asking about a specific states and places if there's opportunity there. So I'm going to ask about New Hampshire and also New York. It's asking if there are any reuse solar panels opportunity and dispose in these 2 areas.
Yeah, we collect now in Maine and New Hampshire. It opens actually to a question I wanted to emphasize, that a big mistake that some states are considering is using the term hazardous waste or universal waste at the point of generation. When I was working with EPA, I said it was extremely important, back in 2007, not to toe tag a living patient, because the purpose of tracking hazardous and universal waste is to see where it went. And if you're looking for people at the morgue, and you've been toe tagging living patients that are walking off, you've broken your entire accounting system. So we believe that determination of whether it's a waste, it can't be hazardous waste or universal waste if it is not yet a waste. And you need the recycler, the expert, to be the one that determines it, at which point it's the source of generation. Some states out there are saying, it is a waste once it is electively upgraded, once somebody chooses to stop using it, and that can be a real problem for us.
Thank you. And there's also a question if you serve in Connecticut as well. So for Robin and Glenn, there was a question in, as you said, New Hampshire was answered, Connecticut and New York.
We're close enough to accept them from Connecticut. I haven't sent any trucks down there yet.
Yeah, we'll accept panels from anywhere and we'll send a truck anywhere. We just want to keep them out of landfills. It's just a matter, like Robin said, the economics of the cost of transportation and the recycling fees are basically fixed. So, it's just a matter of how far, how many, and in the condition.
Yep. Thank you. A question here, is there consistent supply and process for procuring Second Life panels in good condition? And what about the supporting equipment like mounting inverters and cables?
Um, Emmanuel Nailite again, who's much more of an expert than I am, and you should consider having a follow-up panel where you have African buyers, describing what they do. But one of my plant foreman actually in Brockton, Massachusetts, Sanson Mendez, he's 25 years old. He's been working for me for 5 years. He's from Cape Verde and speaks Portuguese. So we actually flew him to Angola to meet with the buyer last November. He spent 2 weeks there and, came back with, well, there's these Chinese uh, uh, stores where they sell the inverters, and that everything that we can't send along because it's for 110 volt. That's just a cost that the Africans know they have to buy something new to retrofit it from China. So it was just an economic problem and not uh, an impossibility.
I
Yeah,
think,
for us,
sorry, go ahead.
basically, we're in the same position that we provide the solar panels. We can give you guidance on what else you need, but we're not supplying or supporting that.
Okay. And I think what Robin was saying also supports another question here, that it was the person would love to learn more about how panels from the US at reduced efficiency can be cost effectively installed in other countries. Or is it a situation where they provide the stability that the region does not currently have, or incentivize it?
Well, as with used electronics, I've never seen anyone export to a place. It's always importing from. And it's the buyer who's coming here, paying for the cost of shipping and transportation. And I have never seen anybody that wants to lose money on this. So, what we try to do is incentivize them to answer those questions for us. And that's why the GPS blockchain thing, to be able to track these things, by the thousands as they're put up, is, part of how we make people feel comfortable listening to, an African or South American if they want to buy this stuff. We don't see as much demand for secondhand in Asia just because China is producing so many panels there. And we don't like competing in price with North Korea and Pakistan opium farms. And that's another reason why we are trying to tell people, hey, pay a little bit more for the accountability, for the GPS blockchain tracking, the promise to know if this is working out. And, who knows, 3 years from now, we're going to know a lot more about the barbershop market, because I do completely understand what Emmanuel and Shang and Sansan are saying, that there's a huge demand for electricity in rural areas where they don't have the cash to pay all at once for a panel. And if African can develop a utility model where they're leasing the panels and collecting a dollar a piece, that could greatly reduce the wattage and efficiency demand, because these are villages that everybody in the village has a cell phone to charge, but 100 cell phones don't need more than one solar panel to meet their needs.
Thank you so much. It was such a good conversation that we did pass a minute of our time. And thank you again for Glenn, Robin, and John for participating in this webinar. For everyone watching, thank you for participating and being here. Again, this is being recorded and will be shared on our website as well as all the presentations. Thank you all and have a good day.
Thank you.
Thanks, everyone.
See you guys later.